So you might be wondering, what's even the point of all this? Good question. So most commonly you actually use the condensing to actually solve equations. And there are a couple ways you'll do that. So last time we learned how to solve logarithms, but we didn't have cases where there were numbers in front that we couldn't deal with and whatnot. And we also didn't have cases where there was a log on both sides. So the way this works, and there are actually a couple different ways you could work this out. So for instance, this one, I could move those in as exponents first, or I could just go ahead and divide both sides by 2, which I'm going to do because it just makes my life a little easier. But I'm still going to have to eventually move an exponent in. So I'll move that 3 in as the exponent. So I have log base 4 of x equals log base 4 of 2 cubed. Well, if you recall last time, to get rid of a log, we apply the inverse being base 4, and so those will go. And we have x is equal to 2 cubed, where x equals positive 8. Last thing I do is just check the argument or the base, wherever the x, the variable is. When you plug it in, do we get something greater than 0 or positive? We do. So let's go ahead and do another one. So careful, because it's not like we always have to use the condensing rules. We could right here, but if you recall last time, one thing I always tell you to do is if you see a log with no variables, please simplify it down first. So log base 2 of 4 is the same thing as 2. So we have 3 log base 2 of x minus 1 plus 2 is all equal to 5. So I could subtract 2 from both sides because we do need to get the log by itself. So we have 3 log base 2 of x minus 1 equals 3. Then we're going to go ahead and divide both sides by 3. So I get log base 2 of x minus 1 equals positive 1. And then it's just actually just a problem like last time, where I apply that inverse. So exponentials are inverses. And we match the base, so it was base 2. So I have x minus 1 equals 2 to the first, or just 2. And then I add 1 to both sides, and you get x is equal to positive 3. Once again, I check my argument being x minus 1. So does 3 minus 1, is that greater than 0? Yes, because 2 is greater than 0, so we are good. Let's do a few more of those, and let's see problems where you actually are forced to condense a little bit more. So that second one, we didn't need to condense at all. We could have. So I could have made that my exponent and then multiplied. The first one, we did have to condense a little bit. Sometimes you'll see something like this, where you'll have 2 logs. They both have variables. I can't simplify them. This is a prime example where condensing is necessary, because you can only have 1 log per side of the equation. So I am actually forced to condense. So first thing I'm going to do is condense these arguments. So I'll multiply the arguments together. So you'll get log of x squared plus 3x, because I'm just multiplying through. And that equals 1. At this point, we're once again going to get rid of the log by applying the inverse. The base of a common log is base 10. So I'll apply a base of 10 to both sides to make it an exponential. And so I'll get x squared plus 3x equals 10 to the first, or 10. This is a quadratic, where there's a quadratic term and a linear term, so I will have to get it equal to 0 so that I can then factor. So this factors to x plus 5 and x minus 2. So my zeros would be negative 5 and positive 2. Once again, you always need to check for extraneous solutions. So what you'll notice is if you plug negative 5 in for the x, you get a negative argument, which we are not allowed to have. The 2 will be fine, because even 2 plus 3 is still positive. So negative 5 is extraneous. You get rid of it. And that's just because it makes your argument negative. But the 2 you keep. So your answer is only x equals 2. Let's do another one once again. We have 2 logs on one side, and you're only at most allowed to have 1. Now it's subtraction, so if you recall, that tells us I'm going to have to divide the argument. So I'll have x plus 1 on top and x on the bottom. So we have natural log of x plus 1 over x equals 3. And then our last step is to apply the inverse. So the inverse of a natural log is base e. Those cancel, so I have x plus 1 over x equals e cubed. Well, this gets a little challenging, and there are a couple ways you could apply this. I don't care what method. I'm going to go ahead and just multiply both sides by x, so I don't have any fractions. So I'll have x plus 1 equals x times e cubed. Then I'll go ahead and subtract x from both sides. So 1 equals x e cubed minus x. Now I did that because I want to get all my x's on one side, and I'm actually going to factor them now. Factor out an x. So I'll get x times e cubed minus 1, and then I can divide both sides by e cubed minus 1. So I get 1. Do I have room? Nope. I should have planned more space for that. Move this up just a little bit. There we go. So I'll have 1 over e cubed minus 1 is equal to x. So at this point, you do need to check your answer. Since it's x plus 1, as long as e cubed minus 1 is greater than negative 1, we're good. So we're just got to make sure it's greater than negative 1 because has to be greater than 0. Actually, it has to be greater than 0 because of this one. So, and e cubed is going to be a positive number, and it's going to be pretty big. So if you type that into your calculator, I don't know the number exactly, but it is bigger than 0. If you do 1 over e cubed minus 1. So we are good to go.